Hey guys, welcome to your 1.3 notes. All right, so this time we are recording it. You're going to watch this, fill out the notes, and then we'll ask questions in class. All right, the first thing we have is our vocabulary. A lot of these vocabulary words you probably have seen before, and other ones are going to be probably new, like the word prime or composite. Okay, those are some newer words to some of us probably. All right, so the first thing we have is the word product. Okay, when you have the product of two numbers, that is talking about multiplication. All right, that means to multiply. Um, we've used the word times as well before. You have all those different words to mean multiply or mean product. Another new word that always means division, to divide, is quotient. Okay, that is one that you're going to see a lot more in math. Not one that we use a ton in the real world, but you have to realize that means to divide. All right. The next one is dividend and divisor. Okay, those are two very similar words. What that really is talking about is when we have a fraction. So oftentimes we might have a fraction like this. We see the fraction line, and we have a top number, right? And we have a bottom number. All right, the dividend is the top number, okay? So that is going to be our top number. And the divisor is going to be our bottom number. So we go ahead and add a text box in here. And we have our dividend. And then we also have our divisor. Now, it'd be nice if math just said top number and bottom number, but that's not the case. So we got our dividend and our divisor. All right. We have prime numbers. Now, prime numbers are very unique numbers in math. We're going to talk about them a lot this year, and you guys will take college algebra next year, a lot of you guys. And we'll talk about that a ton in college algebra. A prime number, I'm going to type this out, is a positive integer, which is a number, right? With only the only factors, integer, with the only factors being 1 and itself. All right, so what does that mean? Well, it's numbers like the number 5. What two numbers can multiply to 5? Well, there are only two numbers. The only two numbers that can multiply to 5 is 5 and 1. That makes 5 a prime number. All right. So a prime number is only when a number has two things that equal itself. So that's being 1 in itself. All right. So I'm going to type out a few more of those, give myself some space. Do another text box. So some of our prime numbers are 1, 2, 3, 5, 7, 11, 13. Okay, those are some prime numbers. Okay. The composite number is the exact opposite. It's a positive number, integer, that with more than two factors. So that's pretty much all those other numbers in between, right? So like the number 4, we used 5 earlier. We'll use the number 4. The number 4 has two different ways you can get to it. You can do 2 times 2. And 4 can also be 4 and 1. That makes it composite. Composite means it just has more than one way to get to that number. All right. That way in so that's more than one way. So when you roll 2 dice, we'll get to that later. Okay, so a positive integer with more than two numbers. We're going to go ahead and write a few more of those out. So some other integers would be so So like the number 15, right? So the number 15, you can do 3 and 5, 3 times 5. You also could do 15 and 1. So that's another example of a prime number. 25 would be the same thing. So those are some examples, 4 and 15. All right. So the next part, we're talking about finding the product or the quotient. So product just means multiply two numbers. Quotient means divide. All right. So in this situation, you guys can use your calculator. If you're not as good with mental math, it is completely up to you. But we're going to do negative 10 times 6. Well, a negative times a positive is going to keep us with a negative number, and that is going to end up giving us the number negative 60. All right. We'll have you guys do this one on your own. So that should be filled out on your notes. I'm not going to do it with you guys, though. This one, we have a negative divided by a negative. Well, a negative and a negative is going to make a positive. All right. So negative 81 divided by negative 9 is actually going to give us positive 9 as our answer. And then the last one, I will tell you it's going to be negative, but I need you to fill that in, and I need you to fill that in. Okay. So those are two practice problems right there. All right. So now the next part, we need to decide if these numbers are prime or if they're composite. All right. So the first thing we want to do is we want to think, what other numbers can go into 12? Well, we obviously know 12 and 1 make 12, right? 12 times 1 is 12. So we know for sure that there's those ones. If we can find one other one, then now it is composite. So one method you guys can do, if you're not sure of mental math, you can always just take the number 12, divide it by 2, divide it by 3, divide it by 4, and keep going until you get a number that isn't a decimal. So if you do 12 divided by 2, you're going to notice that you get 6 and 2. Okay. So 6 and 2. And you're going to, if you keep going, you're going to notice that 3 and 4, right? So this is definitely composite because there are more than one solution. So I'm just going to go ahead and write composite. There we go. 7. Now 7 was one of the ones in our example. 7 only has 7 and 1. So in that case, we're going to just write, we know right away that it is a prime number. Primes are easy. We're just done. Once you notice it's prime, it's prime. 140. Now 140 is a little trickier. Usually the bigger the number, there's more of a chance of it being composite. Another hint is if it ends in 5 or 0, if any number ends in 5 or 0, you know the number 5 will go into it. So it's very likely it's going to be composite. So I will make a list. 28 and 5 go into it. So 28 times 5 is 140. 14 and 10 equals 140. 4 and 35. And then 2 and 70. So those are all numbers that if you multiply those two together would get you 140. So it's for sure composite. And again, if you went in your calculator and took 140 divided by 1, 140 divided by 2, 140 divided by 3, 140 divided by 4, you would find some of these answers. That is the long way. That will always work. That is the long way, though, okay? We'll show you some shortcuts to that here in a little bit. And then the number 2. The number 2, 2 times 1, 1 times 1, no. It's prime, okay? There's nothing else that goes into it. All right, there we go. Prime and composite, just identifying those. All right. The next thing we have is prime factorization, okay? Now, this is something that you guys should have done in the past. This is where we make the prime tree, all right? So you guys have probably seen this before where we make these trees and we want to break it down as far as we can until it becomes prime, okay? So usually using the number 2 works well. You can do 48 divided by 2 and then take that number and divide it by 2. It doesn't always work, but it's a great way to start. So if we take 48 and we divide it by 2, you're going to get 24. And 2. Now we know 2 is prime, right? So we don't have to break that one down. But 24 can get broken down into 12 and 2. And then 12 can get broken down into 6 and 2. And then 6 can get broken down into 3 and 2. And 3 is a prime number. It can't get any smaller. And 2 is a prime number. It can't get any smaller. So we officially know that this is our prime factorization. And so now what we're going to do is we're going to take all of our prime numbers, so all of these guys, and we're going to write them together. So we're going to take all the ones at the bottom of our tree, or like our leaves almost, right? These could be our branches. And our final answer is going to be 48. And then what is the prime factorization of it? Well, it's going to be 2 times 2 times 2 times 2 times 3. All right, so 1, 2, 3, 4 2s, 1, 2, 3, 4 2s, and a 3 and a 3. That is our prime factorization. All right, now the same thing we're going to do with 120. So let's break that guy down. Go back to red, 120. It ends in a 0, so most likely a 5 or a 10 or a 25 is going to go into it. We can do 10. Okay, 10 is a nice one to start with. I know 10 times 10 is 100, so 10 times 12 is 120. Okay, and then 10 breaks down into 5 and 2. Now those are both prime, so that side's done, but I can still break down my 12 to 6 and 2 and 3 and 2. Okay. Now this one's a little sloppier, so I'm going to go ahead and circle all my bottom numbers. So it's these two, and there's all my bottom numbers. So 5 times 2 times 2 times 2 times 3 all equal 120. You can even check your answer by putting those all in your calculator. All right, so that is prime factorization. Sometimes it is tedious, so that's why I usually only give you 1 or 2 of those to practice. But those are our prime factorizations, okay? The next one, we have some application problems. Okay, so these are kind of more of like the real world problems. And this is what you want to use your highlighting tools and using your markers to read these. So if you spend $5.75 each weekday for lunch in a week, how much will you end up spending? Okay, so we know we're spending $5.75 every day at lunch. Okay. Some of you guys actually might do this in the cafeteria. You can actually probably find out how much money that you use of your parents' money, right? I mean, buying food isn't cheap. You spend $5.77 each weekday. Okay, so now we have to think, what are considered weekdays? Well, you love the weekends. So what days are considered the weekends? So that's your Saturday and Sunday. So we know there's 5 days in a week. And if we spend $5.75 every single day, that's $5.75 times 5, which gives us the answer of $28. $28.75. $28.75. And then if you times that by 180 school days divided by the amount of weeks, so 5, you can find out how much you spent for the entire year. Okay. The next one, we have 5 books that cost us $73.50. So all of those combined cost this much. We want to know how much each book costs. Okay, so this is where a division problem is. We got to use a division problem. So I'm going to insert my division right here. or actually this one. Where is it? You don't have to do it this way. I'm just showing you guys another way to do it. I know it's on here. Right there. All right. So we have $73.50 on the top, and we want to divide that by 5 to find out how much each book costs. So then we are going to have our equals, and we put that in our calculator, and we find out it costs $14.50 per book. Okay, so we took the total amount, we divided it by the number of items we have, and we find out how much each one costs. The last one, if John saves $140 per month for 11 years, how much money will he have? All right, so we have $40 per month. Okay, so how many months are there in a year? Well, there's 12, so times 12. And then how many years is he doing it for? For 11. So if you're able to put $40 away every single month for 11 years, you would end up saving just enough to maybe buy a used car. So we're going to go ahead and text box. You put that in your calculator, you're going to get $5,280. Okay. So that is our notes for the day, guys. You'll see that is our notes. Okay, it's ended there. We got a few word problems. We're talking about prime and composite numbers, and that's pretty much it. So go ahead and watch these notes and fill out your notes as you're doing it, and then you're going to submit those back into Classroom. Okay. Then we'll meet again on, I think it's Tuesday or Wednesday, right? All right. So we'll talk more later.